Welcome back everyone. In our previous session we talked about the application of KNN to the iris dataset. In this session we're going to talk a little bit about distance matrix because Minkowski, one of the way that you measure distance, popped out, and we want to actually dig into the documentation itself just to understand a little bit more. This is what I actually copy from the scikit-learn documentation. As a reference, there's really a couple of types: the Euclidean, the Manhattan, the Chebyshev, Minkowski plus weighted, and also Minkowski and also Euclidean. Okay. Now I'm gonna leave the rest for you to actually discover. I want to just cover the first three: Euclidean, Manhattan, and Chebyshev, just so that you actually have a little bit of understanding of them. This is going to be a short session just to understand how the KNN machine learning algorithm actually works. The source of this is from Rasa's blog. Please feel free to actually pay a visit to their site. I find their description is succinct and to the point, just to actually help you to actually come to terms with their distance measure. So let's start with Euclidean. It is the most common one. It's the L2 norm of two vectors. Essentially, this is really, if you have 2 points here, 1, 2, and 3, 3 is 1 minus 3. So that means you take the x1 and then you take minus the x2 and then you square it, and then plus 2 minus 3 squared and square root the whole thing. Okay, that gives you a distance of that. So that's really Euclidean. Basically, it's the straight line connecting 2 points, and it's the direct and the fastest way to it. And then you have the Manhattan. It's L1 norm of two vectors. Basically, you sum the absolute value of the difference between the elements of the vectors. So how does that work? So again, we have 1, 2, and 3, 3 as our coordinate here. For the x coordinates is 1 minus 3. Again, is x1 minus x2. Take the absolute, and then x, I guess you can call this y1 and minus y2, and then take the absolute, which gives you a result of 3. So if the Euclidean distance marks the shortest route, really the direct straight line, the Manhattan's distance marks the longest route, meaning resembling the directions of a taxi moving in the city. This is why it does actually have another name called taxi cab or city block distance. Why is that? And the reason is really simple. It's basically because you are actually taking the absolute. You take, if it's negative, then you absolute. You take the, you're always converting it to positive. Chebyshev distance takes the distance or the maximum of the absolute difference between the elements of the vectors. So in the machine learning space as we are in now, the Chebyshev distance can prove useful when you have many dimensions to consider, and most of them are just irrelevant or redundant. So again, continue with the example that we have is the distance is simply 2, meaning the maximum between 1 minus 3 and absolute 2 minus 3. So this should be difference between absolute. So you're taking the actual maximum itself, so which is this one here is 2 instead of this is 2, this is 1, so it's just basically take the actual largest number of the two. So I guess the other way to look at it is that you can how a king move in a game of chess, or in warehouse logistic, the operations required by an overhead crane to move a crate from one place to another. So it's really the maximum of the absolute difference between the elements of the vectors. So that's really the background of the couple of different types of distance. Then the natural question that you're going to ask is, hey, Anthony, you never talked about Minkowski because that seems to be the default that used by scikit-learn library. You are absolutely right. I haven't actually talked about that at all. So Minkowski is this one here. It has a P here. If you look at this carefully, you will notice that it actually bears some resemblance to this, and this as well. The reason is, yes, it is true. They are actually very similar. If you take P is equal to 1, the argument of P is equal to 1, what you actually get is Manhattan's distance. If you take P is equal to 2, you get a Euclidean distance. Okay, and if you set the limit that P is equal to infinity, then what you get is Chebyshev. Okay, I hope that is useful to you. At least conceptually you understand the difference between Euclidean, Manhattan, and Chebyshev, and also Minkowski. With that, I'm going to end this segment of the lesson. We're going to move into application directly to a dataset called Wisconsin as a diagnostic dataset that actually help to diagnose whether a cell is malignant or cancerous. So with that, or benign, I should say, malignant or benign. With that, I'm going to end this lesson. I look forward to seeing you in the next application video. Thank you.